Proportional reasoning is the type of thinking where you try to figure out how multiplying one variable in an equation affects another. And you're trying to do this without knowing the original value of the variable. We're going to think about this by looking at two examples. In the first example, you're hosting a sandwich party for you and 9 of your closest friends. A party sub is a long sandwich, sometimes 6 feet long, that's cut into smaller sections so that everyone can share. Our goal is to figure out how the length of the party sub corresponds to the number of people that can be fed. Let's say we have a party sub of length L, and I'm not going to give you an actual number for that, but we will say that the party sub can feed 10 people. We're assuming for this problem that each person eats the same amount of party sub. We're going to now look at a new party sub that's of length 2L and figure out how many people that can feed. You've probably already intuited the answer, but we're going to set this up with a set of equations because this is going to help us down the road. We're going to start by defining our variables. Let's say that y is the number of people that can be fed. L, we've already said, is the length of the sub. And we need to have some constant that's telling us how many people can be fed for a certain amount of sandwich. So we'll just call that A, and that's the number of people that can be fed per length of sandwich. Now, the units for this don't exactly matter. In physics, of course, we would be using meters, but we just need some constant that's telling us the relationship. Now we just need the equation to relate them. So y is the number of people being fed, and so to get that, we're going to multiply A times L, the number of people being fed per length, times the length. I'm going to show you two techniques that you can use to solve this. The first one might be more intuitive, but the second one is more strategic and rigorous that you can apply to any scenario. In the first technique, we just look at our equation and see what happens when we change one of the variables. If the length of the sandwich doubles, A is a constant, and so it's not going to change when the length of the sandwich changes, so y has to double as well in order to keep up with it. So y is twice times 10, and so we feed 20 people with the doubled sandwich. That was our first technique, so let's take a look at the second one. For our second technique, we're going to take a look at the equation that we established, and then we're going to write it down 2 more times. Next, we're going to add subscripts to each of our equations to represent our 2 scenarios. So the one on the left is going to be our original sandwich, the one on the right is going to be the sandwich when it's doubled. We know that y1, the number of people from the original sandwich, is equal to 10, and we know that L2 is twice the original length of the sandwich, so we can write L2 is equal to 2 times L1. Next, we substitute that L2 is equal to 2 times L1 into our equation on the right, and then we're going to rearrange things a little bit so that we see that y2 is equal to 2 times A times L1. Well, if we look at our equation on the left-hand side, we see that A times L1 is equal to y1. So we can replace A times L1 with y1. And so we see that y2 is equal to 2 times y1, the result that we got before. So 2 times 10, we see that y2, the number of people that the doubled sandwich can feed, is equal to 20. Let's look at a second example that might not be as intuitive, a pizza party. We have a pizza of diameter d, and let's just say that that pizza can feed 5 people. Now, just like with the sandwich, we know in real life, different people will eat different amounts of pizza, but we're just going to assume that this proportionality holds. It's probably easier to think of our pizza as being cut into tiny little squares for reasons that we'll talk about in just a moment. Our goal, though, is to figure out if we have a new pizza with a diameter twice that of the original pizza, how many people can that new pizza feed? When we're trying to figure out how many people pizza will feed, what really matters is the volume of pizza that people eat. If the thickness of the pizza is the same, then that boils down to the area of the pizza. And we can think of that as the number of little square pieces. Now, if you want to cut it into slices instead of squares, that's fine, but it's just harder, in my opinion, to imagine the geometry. If the number of people fed depends on the area of the pizza they eat, then we just need to write down an equation that involves the area of a circle. Similar to the sandwich example, we're going to let y be a variable that represents the number of people who can eat. This time a is going to be the area of the pizza, since that determines how much food is available. And we need some constant that represents how much pizza people eat. So we're going to let little a equal the number of people that can be fed for a given amount of area of pizza. Again, the units don't matter that much. In physics, we would use meters squared for the amount of pizza. So now we need to relate this to the variables that we've already discussed, the diameter of the pizza. So we're going to let d be that diameter, and now we just need to write the equation in terms of these variables. So y is going to be the number of people fed, a is the number of people fed per area, and big A is the area of the pizza. So similar to the sandwich, we have y is equal to little a times big A. But now we need to incorporate the fact that we have a circle. So you probably remember that the area of a circle is equal to pi times the radius squared, but we have diameter instead of radius. We know that radius is just 1/2 diameter, so we can rewrite the area of a circle as pi over 4 times the diameter squared. Now we just integrate that into our equation, and we see that y is equal to little a times pi over 4 times d squared. Now we're going to try to apply our first technique, which might be intuitive to some of you, but maybe not intuitive to others. If we double d on the right-hand side of the equation, we see that d gets squared, so that factor of 2 also gets squared, which means, of course, that it's equal to 4. In order to keep up with that change, the left-hand side, the y, also has to be multiplied by a factor of 4. So that means the number of people that can be fed is 4 times the original amount, 5, so 20 people can be fed with the new pizza. For technique number 2, we're going to take our equation and we're going to write it twice. Once for the original pizza, once for the new pizza. So we have y1 is equal to little a times pi over 4 times d1 squared. And then on the right-hand side, we're going to have y2 is equal to little a times pi over 4 times d2 squared. Looking at our given information, we see that y1 is equal to 5, the number of people that the original pizza could feed. And we also know that d2 is equal to 2 times d1. We're going to substitute that into our right-hand equation, but it's important to note that in our equation, d2 as a quantity is getting squared. So we need to think about that being in parentheses, so that when we substitute in 2 times d1, it's that total quantity that's getting squared. Now we're just going to expand that out. Of course, the 2 squared gives us a 4, but we are not going to cancel that out with the 4 in the denominator beneath pi. Instead, we're going to bring it out front. So that leaves us with 4 times a quantity of a times pi over 4 times d1 squared. Well, that quantity after the 4 is equal to y1. So we can substitute that in. And so we get that y2 is equal to 4 times y1. y1 is equal to 5. And so y2, the number of people that the new pizza can feed, is equal to 20.